Dear students, in today's class we are going to see projection of straight lines, particularly n projector problem. So this can be called as an n projector problem. So here the true length of the line and the true inclination with the HP and VP should be calculated. So this is the problem we are going to see. A line AB has its end A 20 mm above HP and 25 mm in front of VP. The other end B is 45 mm above HP and 55 mm in front of VP. The distance between the end projector is 60 mm. Draw its projections. Also find the true length and true inclination of the line with HP and VP. So this is the question we are going to see. So here in previous video we have seen a typical problem on projection of line where the true length of the line has been given and we have calculated the true inclination with HP and VP. But here the true length is not given. We have to calculate the true length and also true inclination with HP and VP. So for that they have given n projector distance, that is 60 mm is given. So keeping this as a reference, we are going to calculate true length and true inclination and we will proceed the projection of lines. So let us see how to do this. So first, as usual, draw XY reference line. After that, plot above HP point and in front of VP point, that is A point. So it is given that the end A is 20 mm above HP. So above HP will be above XY. So we can mark A dash point above HP, that is 20 mm. Take the scale, measure 20 mm from XY. So that should be above XY. So it is 20. So mark one point there. So it is A dash point. So along A dash, draw a locus line. Draw a straight line along A dash. So this will be locus of A dash. Then from A dash, draw one straight vertical line up to XY. This is A dash projection line and extend this line to 25 mm, that is in front of VP. Since in front of VP is given as 25 mm, just extend this line up to 25. So it is 20 and 25. So this point will be A point. Then draw a locus line crossing A point. So this will be locus of A. Okay. Then it is given that the other end B is 45 mm above HP. So we can mark the locus of B dash, that is 45 mm from XY. Similarly, 55 mm in front of VP is given. So we can mark B locus, that is locus of B line at a distance of 55 mm from XY. So that's what I am going to do. Take the scale. So from XY, mark 45 mm distance, that is above HP point. So this is the point 40, 45. Okay. So this is not B dash or B1 dash point. This is the reference point to draw locus of B dash. So draw a straight line. Crossing this point, that should be parallel to locus of A. So this line is locus of B dash. So this is the line where B1 dash point and B dash point will get meet. Similarly, the B point is given as 55 mm in front of VP. So take a scale. So from XY, mark 55 mm. So it will be 55. So this is the point where locus of B will exist. So let us mark the point here. So 10, 20, 30, 40, 50 and 55. So from XY, 55 mm distance. So this is the locus of B. So draw a straight line crossing this point to form locus of B. So that's all, we have drawn all the locus line. So make sure that all the locus line and the XY reference line should be parallel to each other. Better use mini drafter to draw these parallel lines. Okay. So then we don't know the true length of the line. So we have to calculate the true length. So but distance between the end projector is given. So we know what is end projector. The meeting point of front view and top view end, that is front view end and top view end. So when you connect those two end by a straight line, that is called as end projector. So let us draw that end projector line. So that is 60 mm from A dash. So this is the end projector line point. So we can draw a straight line to form end projector. So I am using a different color for easy understanding. So this is 60 mm line. So this will be end projector. So draw the end projector line, that is vertical line crossing this point which we have taken 60 mm from A dash and A. So up to locus of B and locus of B dash. Though this point will be B dash and this point will be B. Okay. So join A dash and B dash to form front view. So this can be drawn using HB pencil since it is front view. So A dash B dash gives front view. Similarly join A and B to form top view. So this is end projector. We all know the straight line that joins the end point of front view and top view gives end projector. Okay. So that's all. So the problem is quite simple. To find the true inclination with HP and VP. So for that the true length line should be drawn. So we all know how the front view is drawn using true length line. So we have drawn one straight vertical line up to locus of A from the point of B1 dash. But here there is no B1 dash. We have to find that point to form the true length line. When you watched my previous video, you could able to understand that we have drawn true length line first and then front view and top view. But here front view and top view has been drawn already. Keeping this, we have to draw true length line. Okay. So the problem will be reverse of those previous problems which we have seen earlier. So just listen carefully. Take the compass from A dash as center and A dash B dash as radius. Draw one arc up to locus of A dash. So this point will be B2 dash. So when you refer the free body diagram which I have shown in my earlier video, you could able to understand how this arc comes. So this will be B2 dash. Similarly, draw the arc taking AB as distance. So towards upward up to locus of A. So this point gives B1. Okay. Then draw a straight vertical line from B1 up to locus of B dash to get B1 dash. So from B1 draw one vertical line that should be parallel to A dash line to meet locus of B dash at B1 dash. Similarly, from B2 dash, draw one vertical line that should be parallel to A dash line up to locus of B. So this point will be B2. Okay. Then join A dash and B1 dash to get the true length line. Similarly, so this is the true length line with HP. Similarly, join A and B2 to get true length line with VP. So if you measure the length, this will be the true length line. So the length of these two lines will be equal. Also we can measure the angle, that is true inclination of the line with HP here and with VP here. So this will be theta and this will be pi. Okay. So that's all the problem. So last and final touch should be given, that is we need to mark all the dimensions. You should not miss even a single dimension. Similarly, you have to write the answer here. That is, they have asked to find the true length and true inclination. So that should be written here. So let us first write the answers. After that, we will mark the dimensions. Okay. So first we can calculate the true length of this particular line. That is A dash, B1 dash, A and B2. So just take the scale and measure the length of the line. These two lines will be equal. Similarly, take the protractor and measure this angle. So when you measure the length, it will be about 72 mm. So that can be written here. Okay, this is the answer. That is, true length line is 72 mm. Just measure this, you will get 72. Similarly, when you keep the protractor and measure this angle, this will be about 20 degree, and the angle of VP, that is true length line with VP, will be 25 degree. So these are all the answer. This can be notated as theta and this can be notated as pi. Okay. Apart from this, you can write what is the length of front view and what is the length of top view and what is the front view angle and what is the top view angle. That can also be written here. Even though they haven't asked in the question, you can write those answers also. Okay. So don't forget to mark all the dimensions that I will mark now. So this is 20 mm and this is 25 mm. Okay. No need to mention mm. Just simply write as 20 and 25. Similarly, the true length line. So you can mark the true length line like this. So this will be 72 mm. So just write as 72. So similarly, on VP, just mention what is the length of the true length line. So it will be 72. Okay. So just draw closed arrowhead. Don't draw like this. Since I am using software, I couldn't able to draw closed arrowhead in crosswise. So you should draw only closed arrowhead like this. Okay. So similarly, the end projectile distance we have drawn 60 mm. So just mention that also. So it will be end projectile distance. So it will be 60 mm. Okay. So that's all. We have marked all the dimensions. Similarly, you can indicate here also as theta and this one as pi. Like this, you can mention this angle, that is theta. Similarly, this angle as pi. So this should be 20 and this should be 25. Okay. So right here all dimensions are in mm. So that's all. So in next class we will see in some other problem on projection of lines. Thank you.